Hello and welcome to our next set of algebra notes. This is our last set for the semester. We're in the very last section, outcome 8 of unit 3. So in the previous section, we introduced solving systems of equations where we had two equations and two variables. I mentioned the fact that if you have more variables, you need more equations. That is a rule that is established in mathematics. For every unknown you have, you need another equation, distinct, unique equation. We're only going to go up to 3 because 3 variables with 3 equations is still really practical. This is something that could be used in the real world. Beyond that, you can solve equations with more variables and more equations, but that's not going to have as many real-life applications. Why do 3 variables have lots of real-life applications? Well, with 3 variables, this is actually how we would deal with the 3D world. In order to find the intersection of different planes in the 3D world, you would take 3 equations that define 3 different planes in the 3D world and find where they intersect. Now, there are actually a few different options for this. So you can have just one solution. We'll probably focus mostly on problems like this. So you can see here, this is a picture showing a plane here, a plane there, and then a plane that's horizontal. And then there's just one point in the middle where all 3 of those planes actually intersect. That's the only point where all 3 planes intersect. You could have a situation like this where there's no solution because all 3 planes never have a point where they all intersect. You can have 2 of the planes intersect, another 2 planes intersect, a different 2 planes intersect, but you can't have all 3 of them at the same time. So this would be no solution. So it's possible to get no solution. Another way to have no solution here, you notice that they are just completely parallel planes. And of course, if they're all parallel, they never cross, and there'd be no solution. It is possible to have infinitely many solutions because you can have 3 planes that cross at a whole line. And so we have infinitely many solutions. So that is possible. It is even possible that all 3 equations define the same plane. And so then again, you'd have infinitely many solutions. So there's actually kind of more options here, but really it boils down to the same 3. Either just one point, no solutions because they never touch, or infinitely many solutions, either a straight line or a whole plane of solutions. We're going to solve these. We're not going to worry about so much all this stuff. I might give you some problems with no solution. We'll see one of those in the notes. But mostly we'll work with the one solution ones. We're trying to try and keep it simple. Now, if you went to a more higher level geometry and algebra, you might see situations with these 3 variables, 3 unknowns, and that kind of stuff. But we're going to keep it simple. This is kind of the furthest we'll get. First off, just like last time, before we get into solving these systems equations with 3 variables, we're going to go ahead and just make sure we can check. The answers to these will be ordered triples. I need to fix that in my notes. It says pair, but I should say triple. A triple, because it has 3 numbers, because there's going to be both an x, a y, and a z, 3 numbers, letters that we don't know the value of. And just like before, this will be in alphabetical order. So we'll put x, y, z. That's just typical. The way people do it is put x, y, z. So that's your order. So that 3rd letter is going to be your z. Just like before, to be a solution, if we want it to be a solution, it has to make all 3 equations correct. So all 3 of them have to be correct if you plug in these numbers for one for x, 2 for y, and 3 for z. That's what we'll do, and we'll see if it does hold up. So first off, first one has x, which is 1, plus y, which is 2, minus z, which is 3, and that should equal 0. Well, 1 plus 2 is 3, and 3 minus 3 is 0. So that first one checks out. So we check the next one. So we plug 1 for x, minus y, which is 2, plus z, and z is the 3, so plus 3, and that should equal 2. Well, 1 minus 2 is a negative 1, plus 3. Well, negative 1 plus 3 is 2, and so it does check out. Last one, the bottom one, we have a negative x, so it's going to be a negative 1, plus y, which is 2, plus z, which is 3, equals 4. Negative 1 plus 2 is 1, plus 3 equals 4. And 1 plus 3 does equal 4, so it works out. So it checked out in all 3 solutions. So that means that this point, 1, 2, 3, is a solution for all 3 of these. So they have to cross out at least one point. Now, it's possible they could cross at infinitely many points. They could all be in the same line. But we know at least that they do have at least one solution, and that 1, 2, 3 is a solution. So yes, 1, 2, 3 is a solution. So that's the idea. We're checking to see if stuff is a solution. We're doing that using this, plugging it in just to make sure it really does work. Because that way, if you're doing a multiple choice question or something like that, you can always go back and make sure it actually works. Okay, so let's actually solve some equations. Now you can use both the substitution and addition method. One method we can't use for these ones is the graphing method because our TID4 calculators are not quite fancy enough to graph a 3D graph. Now the fancier calculators like a TID9 or the TI90 series, you can actually graph 3D graphs, so they could actually solve an equation like this graphically. But that's not what we have, so we're going to have to use either substitution method or addition method for these. Now they get a little more complicated because there's more variables to solve for, but the process is basically the same. We're going to solve one of the equations for one of the variables, and we'll plug it out in the other equations so we can get equations with less variables until we finally get to one equation with just one variable and we're done. So we're usually going to look for the one that's probably the easiest to get a variable by itself. There's a couple options here, so it really doesn't matter which one we pick. Maybe I'll just take the bottom one. I'll solve for x. So it starts off with x plus y equals negative 2z. So I'm going to take this, I'm going to subtract y across. Subtract y across. Just trying to get that x by itself. So if I do that, and then I got x equals negative 2z minus y. And once I get one of the equations by itself like that, I'm going to take that and plug it into one of the other equations. So I'm going to take this all and plug it in for x in one of the other equations. Let's go ahead and plug in the first one. So I take all this and plug it into for x in the first equation. So we end up with 2 times this negative 2z minus y. All that's getting plugged in for x. Still minus z, still equals 7 plus y. Now we're going to take that equation and we're going to try and simplify that a bit. So let's get it down to, make it simpler. So first off, let's go ahead and distribute that 2 through. So we negative 4z minus 2y, still minus z equals 7 plus y. I want to go ahead and combine z's. So negative 4z minus z, that gives me a negative 5z minus 2y equals 7 plus y. So I can simplify this a little bit more if I can get z or y by itself. So let's go ahead and move the y across so we can start working on z by itself. So I'm going to add 2y to both sides. 2y. Get rid of this minus 2y. So negative 5z equals 7 plus y plus 2y gives me 3y. And then we can get rid of this 5 here if we just divide both sides by negative 5. So we can get z by itself. So divide by negative 5. Divide by negative 5. Okay, and so we've got z is equal to 7 plus 3y over negative 5. So again, we're just trying to get one of the letters by itself. So we got z by itself. So now what we can do, since we used the last equation and we used the top equation, let's go back and use the third equation, the one we haven't used yet. So we're going to use that x minus 2y equals 3 plus z. And first off, let's replace the x so we can get rid of the x part. So we just have z's and y's. So replace this x with this whole thing. So I'm going to have negative 2z minus y. Replace the x, still minus 2y, still equals 3 plus z. Then we can simplify this a little bit. Let's combine some like terms. So let's get stuff together. So the negative y and the negative 2y gives us a negative 3y. Still negative 2z equals 3 plus z. I can combine some more. I can add the 2 z's across. I'm going to go ahead and add 2z to both sides. Again, I'm just trying to get rid of this 2z. I really want to get all the z's on the same side, get them all together. Simplify it as much as I can before I plug more stuff in. And so now that I've gotten this, simplified quite a bit, I don't need to worry about solving for y yet, but I'm just trying to get it down to just one y and one z. Then I can take this z part I had and substitute that in. So I plug this in here. So all this stuff, I'm going to plug in for z. So I get negative 3y equals 3 plus 3 times this whole expression, which is 7 plus 3y over negative 5. Okay, so I got rid of everything but y's, and so now I'm down to just solving this for y. So a few things I can do. First off, I can go ahead and distribute. I'm going to distribute this 3 just to get rid of the parentheses. So this is still 3 plus, but 3 times 7 is 21. 3 times 3 is 9. Y, and I still have a negative 5 on the bottom. It's okay when you multiply by 3. You always think of it as a 1 on the bottom, which multiplies times the negative 5, keeps the negative 5, and 3 just multiplies the top. That still equals negative 3y. I don't really want to have a negative 5 on the bottom. I don't like fractions, so I'm going to get rid of them. I'm going to multiply everything here by negative 5, because that will get rid of that negative 5 on the bottom. So negative 5 to the first part gives me a positive 15y. Negative 5 times 3 gives me a negative 15. And then this part, the negative 5 would cancel, so I just end up with the 21 and the 9y. Okay, all that was the work to do to get 1y by itself. And that's really the majority of the work for a problem like this, is trying to get to the point where you have one equation with just one variable that you can solve. And I got rid of the fractions, got rid of some parentheses. Now I'm ready to solve this, so I'm going to get all the y's on the same side. So let's go ahead and subtract 9y from both sides. Get rid of this guy. 15 minus 9 is 6y. Negative 15 plus 21, you combine those, you get positive 6. Last step, divide by 6 on both sides. Get rid of the 6. So you get y equals 1. So all that work, we were doing that just so we could get one of the variables solved. Once you know one of the variables, you can go back and use that to get the other ones. So since z, we know what z is in terms of y, we can plug this in here and find out what z is. So z is going to be 7 plus 3 times 1, divided by negative 5. Well, 3 times 1 is 3, and 7 plus 3 is 10, so we get z is 10 over negative 5. Positive divided by negative is a negative, so z is going to be a negative, and it's a negative 2. How do I put 1 there? Negative 2. 10 divided by 5 is 2. So now we got the y is 1, we got the z is negative 2. The last thing, we're going to go back up to this first one. We're going to figure out what that is. Well, if we know z is negative 2, so negative 2 times 2, and y is 1 minus 1, we can find out what x is. Negative 2 times negative 2 is positive 4, minus 1 is 3. So now we know x, we know y, we know z. If we want to double check ourselves, we just plug those three numbers into those original three equations, make sure they work in all three equations. That's how we double check ourselves. So if you're doing like a multiple choice question, think to know the answer, you can go back and you plug those three letters in and make sure all three equations are true. To write the answer for this, there's an ordered triple. So we put the x first, we put 3 is the x, y goes second, so 1 is the second number, and z goes last, so negative 2 is the last number. And that's your answer. That's your ordered triple. It's got x, y, and z. That's the idea. Substitution, again, we pick one of the equations. It doesn't matter which one you start with. Just pick one of the equations, solve for a letter. It's going to have the other two letters because there's 3 of them. That's okay. Take those and replace it in a different equation. Never go back to the same one you started with. Always use a different equation until you used all 3 equations. You can see I started with the green equation, and then I plugged that into my blue equation, and then finally I plugged that stuff into my orange equation. So I always use all 3 equations, because it's easy if you're doing this when you have so many steps to maybe accidentally use the same equation twice. If you don't use all 3 equations, you won't get the answer at the end. You use substitution. Let's try another one so you can see another example. And it is a lot of steps, a lot of work. So that's something to watch out for. We do have a whole section on this, so it will be on the exam. So you just got to be ready for this, solving this, because you'll hopefully you do all the homework and get ready to solve these. Okay, let's try another one. So again, I'm going to pick whichever equation I want. I'm going to solve for one of the letters. I think I'll pick the bottom one. So this one, I'm going to start with the bottom one. I'm going to make this from my orange equation. I'm going to solve this for z, because that's kind of an easy one to solve for, because I can just add x across. So I'm going to take that z minus x equals 3 minus y. I'm going to add x to both sides. Because by doing that, I can get rid of the x here. So I can get z by itself. And see that z is 3 minus y plus z. Or sorry, x. Not z, x. Why did I say z? Okay. Now that I have that solved for z, I'm going to take that and plug it into one of the other equations. It doesn't matter which one. Let's go ahead and let's go to the middle one next. So let's go to this middle one, plugging in there for z. There's only one z, so that's fine. This one in green. So I make 2, and instead of z, I'm going to have all this stuff. I'm going to have 3 minus y plus x minus 2y equals 2 times 1 minus x. They put a lot of stuff there just to make it look more complicated, but it's not a big deal because it's just parentheses that you always distribute to get rid of. Same thing here, we'll just distribute the parentheses because we have that 2 times the z, so all this stuff got multiplied by 2. 6 times 3 is 6, 2 times negative y gives me 2y, 2 times x gives me 2x, that's 2y, 2 times 1 is 2, 2 times x, I get negative 2x. Combine some like terms, we've got a negative 2y and negative 2y, those combine for a negative 4y, still plus 2x, with the 6 in front, still equals 2 minus 2x. I'm going to go ahead, I got to pick at this point which one to solve for. I'd probably get y by itself, so I'm going to subtract 2x from both sides. Subtract 2x, so get rid of this guy. I'm also going to go ahead and subtract 6 from both sides. So I'm trying to work on getting y by itself. And I just picked, I can pick whatever letter I want to get by itself, and I just picked the y in this case. So I got negative 4y on this side because I got rid of everything else. 2 minus 6 is negative 4. Negative 2 minus 2 more is negative 4x. Don't forget the x. Here I want to get rid of this negative 4, so to undo multiplication I divide, and I divide both sides by negative 4. Which gets rid of the minus 4 here, and we just get the y, because we got rid of the negative 4. Over here, make sure you divide both parts by negative 4. Negative 4 divided by negative 4, that's just 1. Negative 4 divided by negative 4 is also 1, and it's a positive 1, because the double negative makes a positive. Don't forget the x, so 1x or just x. I guess I could just put 1 plus x. I don't know why I put 1x there. Okay. So we solve for z, we solve for y, both in terms of x. We're not done yet. Now we take what we just got and we plug it into that last equation. So the one that we haven't used yet, I'll do this one in blue, my blue equation. That was my green equation. Because again, we want to use all 3 equations. So it's always good to kind of mark that you're using all 3 equations. So the first one here, I'm going to leave the x, but the y, we can replace with 1 plus x. I'm going to go ahead and replace that one right now. 1 plus x. The other one, the z, I have to replace with all this. Now you can kind of do this 2 ways. One, you can actually replace the y here already with this one, or you can go ahead and just replace the z in the equation and then replace the y later. So it doesn't really matter which way. I'll do that. I'm going to go ahead and replace the z with all this stuff. So 3 minus y plus x. That replaces the z, and then it's still minus 3. So I'm going to do that first, and then I'll go ahead and replace the y as the next step. So on this side, I'm going to go ahead and combine some like terms. We've got x plus x is 2x plus 1. Over here, I have 3 and negative 3. Those actually cancel, right? They're opposites. They cancel. Y here is 1 plus x. I'm going to replace that with 1 plus x. But because it's a negative y, I'm going to put that negative in front, parentheses. So I make sure that both the 1 and the x get that negative. Don't forget the plus x there. Okay, so we can distribute. Get rid of the parentheses. So we get negative 1 minus x plus x, 2x plus 1. Combine some like terms. You can see the minus x and the plus x there cancel. Let me go ahead and subtract this 1 across, because eventually I want to get this x by itself. So I'm just doing that to get rid of that plus 1. So 2x equals negative 2. And then divide by 2 on both sides. To do that multiplication, we divide by 2. Get rid of that 2. And we see that x is negative 1. And that's the value for x. So we did, we solved for x, we got one of the variables. When we get one of them, we're most of the way there. The rest of it's just plugging that number back in for that letter to find the other variables. So I can go over here, where I have y in terms of x, y equals 1 plus x, and just replace the x with negative 1. So y is 1 plus negative 1. Well, 1 plus negative 1 is 0, so y is 0. And the last one here, we're going to replace both the y and the x. Y we just figured out was 0, so replace that with 0. X we figured out was negative 1, so that's plus negative 1. Still 3 minus, but here it's just subtracting 0. We get 3 minus 0 is 3, plus negative 1 is 2. And that's our z value. So that's the idea. You want to kind of substitute stuff in until you can get down to one letter. Every time you see me substitute, you should see that when I substitute, I've kind of eliminated the letter in that equation. So I can get down so I have less letters. So the first substitute, I get that equation down to it only has 2 letters. Once I substitute the first time, I ended up with an equation with just 2 letters, y and x. And then I substitute again, I was able to get down to just 1 letter and solve for that letter. That's the idea with this. You should be able to get to a point where eventually just have the 1 letter by itself. Don't forget when you answer these problems, always put in a nice ordered triple. So we put x first, so negative 1 first, y would come second, and z would come third. And that would be your answer for this set. So negative 1, 0, 2. Again, if this is a show your work question on the test, I'd be fine if you just told me x is negative 1, y is 0, and z is 2. But it should be really clear. You shouldn't leave me guessing which one's which. If you just tell me the answers are negative 1, 0, and 2, but you don't tell me which one's x, y, and z, then I'll take away points. If you put an order triple, of course, that's labeled. It tells me x, y, z. That's why we use the order triple. Okay, I'll do one more substitution. We'll do one more practice for substitution, then we'll talk about addition method after this. Again, you start with whatever letter and whichever equation. Does not matter. You pick. I'm going to go ahead and just start the first one because I can see it's going to be pretty easy to get x by itself again. So that's what I'll do. So I'll start off with this x minus 2y minus z equals 2. I'm just going to try and get x by itself. So first I'm going to add z across. So I'm adding z to both sides. And then I'm going to add 2y across. So 2y to both sides. So doing that to get rid of this minus z, get rid of this minus 2y. So I can get x by itself. I have 2 plus z and plus 2y. So all that just got the x by itself. Taking that expression, I'm going to plug it into one of the other equations. It does not matter which. So I'm going to go ahead and plug in the second equation. So I'm going to take all this. I'm just going to go ahead and plug in the second equation. So the first equation, I use this. The next equation, I use this one. So here I'm going to take this x, this minus x, and replace all the x with all this stuff. So I get minus 2 plus z plus 2y, the whole thing, plus the 6y, because I have a 6y there, minus 3z equals negative 6. So the minus in front here, because there's a minus in front of the x, and all this stuff replaced x. I'll go ahead and distribute that negative to make sure all three parts get that sign, because that negative has to go to everything that replaced the x. So I get negative 2, so minus 2, negative z, so minus z, negative 2y, so minus 2y, still plus 6y, still minus 3z, still equals negative 6. Now I can do some combining like terms. So I have a minus z and a minus 3z, so combine those, I get minus 4z. I have a negative 2y and a positive 6y, combine those, I get positive 4y. I'm also going to go ahead and get rid of this negative 2, because I'm going to have to solve for these letters. I'm going to add 2 across, just to get the numbers on the same side. So I get rid of this minus 2, and just put it on the other side. So it equals negative 4. Negative 6 plus 2 is negative 4. Let's go ahead and solve for the y, just because that'll be easier to get positive. So if I just add the 4z across, and the 4z, I could solve for either. I just went for the y because I thought it's already positive, so let's just leave it alone. So we leave the 4y on this side. The other side we get negative 4 plus 4z. Last step, divide both things by 4, both sides by 4, because that will cancel that 4 there. So we get y equals 4 divided by 4 is 1, so we get minus 1. 4 divided by 4 is 1, so we get plus 1z, or just z. So again, the idea is we're trying to work. The first time we got one of the letters by itself, and then when we replaced it in the other equation, we got one of the letters by itself, and there's only one letter here now. Before there's 2, now there's just 1. So now when I substitute it into the third equation, the one we haven't used yet, so we're going to use the bottom one, when I replace that, I'm going to be able to get down to just one letter. So I'm going to replace the y in it. I'm also going to replace the x in it. So let's replace the x first. So we get 2 times, well, instead of x, I'll have all this. So I'm going to have 2 plus z plus 2y. That's all replacing the x. Minus 11y plus 5z. And so I'm going to replace the z here. Or sorry. No, I'm not replacing it. I guess I didn't replace the y. I'll do it in the next step. 5z equals 11. Y was the one I'm supposed to replace. Whoops. It doesn't matter. I can do it later. I replaced the x, so now there's no more x's in here. So I could replace y's now, but there's a lot of y's. So I'm actually going to go ahead and simplify this a little bit first, because if you can simplify first, sometimes you can make it easier. So I'm going to do that. I'm going to do 2 times 2 is 4. 2 times z, 2z. 2 times 2y gives me 4y. Still minus 11y plus 5z, 11. So now I can combine. I got 4y minus 11y gives me a negative 7y. Got 2z and 5z gives me 7z. I got a 4. I'm going to go ahead and subtract the 4 across now, just to get that 4 out of the way. You can combine it with 11, so I get 7. And now, made this a bit simpler, now I'm going to go ahead and replace the y. So I'm going to replace y with that negative 1 plus z. So I get negative 7 instead of y, I have negative 1 plus z plus 7z equals 7. We distribute, negative 7 gets distributed here, so I get positive 7 minus 7z plus 7z equals 7. Combine like terms here, I have negative 7z, positive 7z, they cancel, and I go, wait a second, something weird's happening here, because I ended up with an equation where 7 equals 7, right? And this is something you should see and go, wait a second, we've seen something like this before, right? And this does happen. This is where these three equations are actually going to have infinitely many solutions. And we didn't figure out if there's just like a straight line where they match or if they're the exact same plane. All we figured out at this point is because this is true, it's not false, that means that there are infinitely many solutions. And you can see this is similar, infinitely many solutions. This is very similar to what we did when we were solving the equations of two variables. Because you'll go ahead and you'll be solving, and then you'll get to a point where you expect it to solve for a letter, but it'll just disappear. You'll end up with a true equation, where it's just got numbers, the letters are all solved away, and that's when you know that there's infinitely many solutions. So that's what your answer is. So in this case, what we would say, usually how we do this is we write the other variables in terms of the variables. So if you want like what the equation solutions look like, sometimes people write the solutions like this. They'll say, so like we know that y is going to be negative 1 plus z. So I'll put negative 1 plus z for the y. Z will just leave as z. So because one of the variables there's infinitely many solutions, so we'll just let z be anything. And then they'll figure out, well, what could x be? And so what we'll do is we'll just plug this in for y in here. So we get 2 plus z plus 2 times that y replaced with negative 1 plus z. I won't do this to you on the exam. I think they might do it on the homework. That's one reason I'm covering it real quick right now. Is if you have infinitely many solutions, they might write the answer like this. So what they're doing is they're just solving for x in terms of z, solving for y in terms of z, and then just leaving z as a variable. So we can say, okay, if you change z, you can figure out what the answers will be. So if you look 0 in for z, what would be 1 in for z? Here we distribute, we get negative 2 plus 2z, and then there's a z plus 2. And so this ends up being, when you have z plus 2z, it's 3z, and 2 minus 2 is 0, so the x just ends up being 3z. So we get 3z, negative 1 plus z, and z. And that's what the answers would look like. Whereas z could be kind of any real number, so you could plug anything you want for z in. But as long as they have that pattern where the first number is going to be 3 times the z, the second number is going to be 1 less than z. If you have that pattern, then that answer will work for the solution set. So this just kind of finds the pattern or the trend to the answers. So if you pick a number for z, you'll find that you can plug in for z and get an answer number. But there's infinitely many of them. So I'm not really worried about this so much as I'm worried about you should know infinitely many solutions. That's what I would look for on the test. On the test, I'm not going to ask for the 3z, negative 1 plus z, but I'm just going to say, how, if you have a problem like this, you just mark the box that says infinitely many solutions. Or if you're solving and show your work, just say there are infinitely many solutions. I really just did that because I think there's some homework questions where they might kind of make you do that, so I wanted to show you that. Okay, so that was substitution. So far we've been doing substitution method. And if you like substitution, if you feel comfortable with it, you can always use substitution method on these. You don't have to use both methods. I honestly think that there's not as much benefit to this one with the addition method as there was in the previous section. So I honestly, most of the time, just do everything with substitution method. I usually don't really worry about doing the addition method with these. I'm going to do it here just to show you, but that's something I kind of should do. I tend to not worry about addition method as much. All right, so let's talk about how do you do addition method. Well, what you do with addition method is you're actually going to pick a pair of equations. So you're not going to use all three to start with, but you pick a pair, and you're going to find a pair that you can add up and maybe cancel something. If nothing cancel, you might have to multiply to make it work, like we saw in the last section. But if you're lucky, you can usually find a pair where at least one of the variables cancels. Like this one, I would take the first equation and the second equation out of these three equations. First and second, I'm going to add those, 1 plus 2. Because those two, if you notice you add them, the z's will cancel. I'm going to do that. I'm going to look for a pair where I can cancel something at least. So I'm going to do 2x plus y minus z equals 3. And they are lined up. Make sure they're always lined up before you start adding. Minus 2y plus z plus 11. Add those up. 3 plus 11 is 14. Equals negative z plus z cancels, and that's where that goes away. There's nothing there. Y plus negative 2y is just minus y, and 2x plus x is 3x. So by doing that, we're able to eliminate a z, and we get an equation that's just x and y. Now what we do is we pick two other equations. Doesn't have to be, or it doesn't matter which pair as long as we don't use the exact same pair. So I could do like 1 and 3 or 2 and 3. Let me use 3 with one of the other two. And we'll add those in a way where the z's cancel. So I'd probably do like 1 and 3, but what I'm going to do is I'm going to take the first one and I'm going to do it times 2. I'm going to double it. I'm going to double the first one. Why do I want to double it? Because right now negative z plus 2z don't cancel. But if I make that a negative 2z plus 2z, then they will cancel. So that's what I'm going to do. I'm going to do 1 times 2, and then I'm going to add to it the 3. That's what I'm going to do. So the first 1 times 2, I get 4x plus 2y plus 2z equals 6. So that's what I get when I double it. The third one I'm just going to leave alone. So I'm going to leave that as negative x plus y plus 2z equals 0. And that way the z's do cancel like they did before. So I get 6 plus 0 is 6. 2y plus y is 3y. 4x minus 2x minus x is 3x. And that's a positive 3y. And so what I've done now is by eliminating z both times, so I'm canceling z both times, is now I have a pair of equations with just x and y. And so from here on out, I can just treat this like a system of equations with two variables. I can use addition method, I can use elimination, addition method, I can graph them. Any method works. I don't have to do it a certain way. But the idea is to always do that first step, to do this method of picking two equations that you can cancel a variable and then pick a different pair, you can cancel the same variable to get two equations with matching variables. So I've got two equations, two variables. Now I can solve from here on out. So I think what I'll do on this one is I'll do the elimination or addition method again. I'm going to add these together, but I'm going to subtract these, because if I subtract, the x's will cancel. So I'm going to take the 3x minus y equals 14. I'm going to subtract the other one. So I'm going to subtract the 3x plus 3y equals 6. So by subtracting them, these x's cancel. So I get those to go away. Negative y minus 3x is negative 4y. Negative 1 plus minus 3 is negative 4. 14 minus 6 is 8. So I did another addition method. No, I subtracted actually. Subtraction method, you could call it. And then I have something where I can solve for y. So I'm going to divide both sides by negative 4. Divide to get rid of that y. To get that y by itself. So we get y equals 8 divided by 4 is 2, and the positive divided by negative is a negative. So y is negative 2. Just like before, once you get one of the variables by itself, you can go back and plug it in. At this point, I can plug into any equation I want. I'm probably going to plug it into one of these two, because if I plug in y, then I can solve for x. Does not matter which ones. I think I'll just go with the left one, just because it does not matter. You can use either one you want. So I'm going to do 3x, but instead of y, I'm going to do minus negative 2. Right? So the negative 2 replaces the y. So that equals 14. Well, minus negative 2 is just plus 2. And to get rid of that 2, I'm going to subtract 2 from both sides. Subtract 2. So we got 3x equals 12. Divide by 3 on both sides. 3. Okay, x equals 4. All right, so we got y is negative 2. We got x is 4. Last thing we're going to do is we're going to solve for z. So at this point, I'm going to plug these into one of the original equations because those actually have z in them. I'm not going to go with one of these two because they don't have z anymore. I'm going to go back to the original equations. Doesn't matter which one. So let's go ahead and plug it into the second one because z is almost by itself, so that's probably a good one to go with. So let's use the second one equation. So we're going to use number 2. X is 4, so we got 4 minus 2 times y, which is negative 2, so we're plugging that times negative 2, plus z equals 11. Okay, do some simplifying. 4, negative 2 is 2 is negative 2 is positive 4, so 4 plus z is 11. So that 4 plus 4 is 8, so 8 plus z is 11. Subtract the 8 across, get rid of that 8. Look at z is 3. That's our z. And so there we go. We found all three numbers. We found out x is 4, y is negative 2, and z is 3. And that's the addition method. You do not have to use the addition method. If you like it, you can always use it. You just have to make sure you line stuff up when you do it. You know, if something's not lined up, you always want to make sure you line it up. That's kind of one of the big ways maybe people identify whether they want to use it or not. So like on this problem, all the x's, y's, and z's are lined up. It's a good candidate for addition. The previous problem, x, y's, and z's are lined up, it probably would have been great for addition. Eventually, you'll see some problems where things are not lined up, right? We've got z, y, x, y, you know, stuff parentheses. This one's probably not great for addition right off the bat. You can go rewrite it, right? You can solve and get stuff so it's all in the same order, like this one is. But you have to do that extra step before you can do addition method. If you do substitution, you can just start doing substitution method right off the bat. Okay, I got 2 more examples, and then we're done. That's all this is just doing these 3-part problems. You know, so it's a bit of a doozy of a homework because these take a long time. There's a big process to them. And you never know when you'll hit one where it's no solutions or infinitely many solutions. But this is the idea. So this one, you can see the x's, the y's, the z's, the equals. Everything's lined up. That's what we're looking for. We always want to add to make things cancel. So I'm looking for pairs that cancel. Right now, there's nothing that just cancels right off the get-go. So I'm going to have to pick, you know, what I want to do with my 3 equations. I like to label them. We do 1, 2, 3. So I can make the first and the third one. I can cancel z's again. So let's go ahead and go for z's again if I subtract them. So I'm going to do 1 minus 2. So if I subtract, then I can do 5z minus 5z and they'll cancel. So we do the 4x plus 5y plus 5z equals 5. So I'm going to leave the first one alone, but I'm going to subtract. I'm going to subtract the other one. So sorry, I said 2. I meant 3. I mean 3. So I'm going to subtract this 2x minus 4y plus 5z equals 4. By subtracting, I can make some things cancel. 4x minus 2x is 2x. 5y minus 4y is just positive y. 5z minus 5z, those cancel. And we get 5 minus 4 is 1. So that's one of our pairs. We need another pair. So I got to use 2 equations. Again, it doesn't matter as long as I don't use both 1 and 3 again. I can use 1 and 2. I can use 3 and 2. I get to pick. Doesn't matter otherwise. Let's just do 1 and 2. So I'm going to do 1 and 2. I'm going to make these cancel this time. I'm going to take that 1 and I'm going to multiply it by a negative 3. So if I take 5z times negative 3, I get negative 15. We'll cancel with my positive 15. So I'm going to have negative 12x, because negative 3 times 4, minus 15y, negative 3 times 5, minus 15z, and negative 3 times 5 gives me a minus 15. And we're adding the middle equation, so 12x plus 15y plus 15z equals negative 5. Now I've got to add these, and you notice something kind of crazy happened, right? The z's cancel as we expect, so do the y's, so do the x's, so I end up with nothing on this side. But over here, negative 15 minus 5 actually gives me a negative 20. And so what happens this time is we go to solve it, and we actually end up with an equation that's false. This one is false. So this is what happens when your 3 equations never ever intersect all at the same point. So this one has no solution. So these are 3 planes that never quite cross. You know, they might do the stacked parallels, or they might do this weird shape here where it looks like a tent with a floor, but they never quite touch anywhere. They don't have a single point or a line where they all cross. So this one actually has no solution. So we're done. Right? That's all we had to do on this one. We don't have to do any more work because we did this part and noticed, oh, already it doesn't work. There is no solution that's going to make all these work. So we can quit. We can say, nope, this doesn't work. Okay, last one. I'll do one more that works just to finish it off. Again, we'll use the addition method. So again, we're going to label these. We're going to do 1, 2, and 3. Again, I'm going to look for things I want to cancel. So I could do that. What was these again? I could do y's. I could do x's. does not matter which one. So I can pick. Let's cancel y's this time. We didn't cancel y's. We canceled z's before. Let's cancel y's. So we're going to cancel y's. Just change it up and do it different this time. So cancel y's. To do this, first off, if I do 1 and 2 and cancel y's, actually that's kind of a pain. So let's skip that. Let's do 1 and 3. 1 and 3 is a little bit easier. So 1 and 3, we just need to make the bottom one multiplied by -2. So I'm going to do 1 plus, 3 times a -2. So if I take this times a -2, then that will give me a -2y plus 2y don't cancel. So that's what I'm going to do for the first one. The first one, I'll just leave it alone. 4x plus 2y plus 3z equals 0. The bottom, I'm going to multiply by -2. So we get 6x minus 2y plus 2z equals -2. By doing that, I made the y's cancel. That was my goal. I wanted to make those y's cancel. 4 minus 6 gives me -2x. 3 plus 2 gives me a positive 5z. 0 minus 2 gives me a -2. Okay, that's one set. Now I gotta do a different set. To change it up to do different, I'm gonna go ahead and use 2 and 3. So I did 1 and 3, now I'm gonna use 2 and 3. Again, I'm looking for the y's to cancel. So I'm gonna take the second equation, I'm gonna add the third equation, but the third equation I'm gonna multiply by 3. Because if I triple the bottom, then they'll have a 3y and a -3y that will cancel. So the first one we leave alone, we get 2x plus 3y plus 2z plus 8, but the bottom one I'm going to multiply by 3. So you get 9x plus 3y minus 3z plus 3. 2 plus 9 is 11, 11x. -3 plus 3, those ones do cancel. That was our goal, trying to get rid of the y's. 2z minus 3z gives me a minus z, and then 8 plus 3 is 11. Okay, so we did it. We got rid of the y's. Now we need to try and get solve for either the x's or the z's. Okay, to do this, let's go ahead and with these do another elimination step. So I'll do, just the easiest thing I think to do here is to take this one times 5. Because then we'll have z's cancel. So I'll take 55x minus 5z equals 55. And if I add those together, the z's will cancel. So I get -2x plus 5z 2 equals -2. I'm going to add the 55x minus 5z equals 55. So the z's cancel. -2 plus 55 is 53x equals, and -2 plus 55 is 53. Divide both by 53. And we can see that x is 1. So that's our first one. We got x is 1. Once we got x, we can go ahead and plug it back in, find z. I'll go ahead and plug it into this one. You can plug it into anyone you want. I'm going to plug it in here. So I'm going to plug in 1 in for x. So I get 11 times 1 minus z equals 11. And try and solve that one. So 11 is 1 is just 11. So I get 11 minus z equals 11. So if I subtract 11 from both sides, this thing, negative z equals 0. If negative z equals 0, well then so does positive z, right? Because 0, when you make it negative, doesn't change. So z is 0. Now I got x and z. I plug those back into one of my original equations and solve for y. I'm going to probably use the bottom one because that's probably going to be pretty easy to get y by itself. So my last step here, I'm going to take that 3x plus y minus z equals 1. I'm going to plug in the x and the y, z I got. So x is 1, so I get 3 times 1. Z minus z is 0. Sorry, y. This is supposed to be y, not a z. Equals 1. 3 times 1 is 3 plus y. Minus 0 is just minus nothing, so we can drop that. Subtract 3 across. Y equals -2. So our answer for this one is 1, -2, 0. And that's our answer. That's our idea. So we're always looking to try and get the x, y, z, figure all 3 numbers. There we go. So that's ordered triples. That's solving a system of equations when we have 3 variables. And this can expand. There are problems out there with more variables. I actually teach in one of my other classes a problem where they have like 8 variables and 8 equations. It's kind of a long problem. We don't really solve it like this because it would be painful, but there are problems out there like that. And they have computers that will help them with the bigger problems. Thankfully, we don't have to do that by hand anymore. But that's what they used to do back in the day. If you gave someone 8 unknowns and they had 8 equations, they'd sit there and substitute over and over again or use the addition method over and over again until they could find out all 8 answers. So the most I'll ever have you do is 3 because this is our last section and we are done for the semester. So this is all our notes. We're done. This is our last set of notes. So you're going to finish up this section of homework. Hopefully you get get through the quiz, start hitting that practice exam and get ready for your last exam. So Unit 3 exam, which is coming up soon. Hope you had a good semester, and I'll see you at the exam. Otherwise, have a great rest of your semester. And take care.